Hello and welcome to the first panel discussion of today's event. I'm sure it's going to be a lively one with the topic of convergence points the way to 6G. 90 minutes is a challengingly short time to address such a huge subject, but we have a brilliant panel here to join me. I'm Caroline Gabriel. I'm a research director at Analysis Mason, responsible for all our networks research. And I'm also the co-founder of Rethink Technology Research. Both of these are companies that specialize heavily in network evolution, operator business models, and their deployment plans for 5G. And now, of course, some leading operators are just starting to think about 6G. So I'm delighted to welcome a panel of experts with direct involvement in many aspects of 5G standards and implementation, and with strong views on how 6G will evolve. I'll introduce them in a minute, but first a few words to set the scene. In the run-up to 5G, there was a lot of talk about the potential for this to become more than a mobile network upgrade and instead become a foundation for a converged network of networks. In reality, we've seen relatively little real-world convergence yet, except above the networks level. Combined billing and customer engagement for fixed and mobile services, of course, is becoming mainstream. But at the network level, the technologies remain pretty much separate. But there is rising interest. I spend a lot of my life surveying and talking to operators around the world about their network deployment plans and their business cases. And over the past 4 years at least, convergence has become an increasingly important item on the wish list. In many cases, this relates to the convergence of fixed and mobile services as more and more operators move towards a multi-network model, often through M&A. There are also issues with Wi-Fi convergence. And of course, telcos are exploring their relationship with the non-terrestrial network sector, especially at the moment with all the hype around the LEO-sat launches. And there are signs of technical progress. The 5G core is far more broadly multi-access than its predecessors. And of course, there is 3GPP work on NTN convergence, which I'm sure we'll hear some more about during our discussion. But there are also many questions, including the level at which operators need convergence. Is this about traffic shaping, orchestration, full network interworking, common devices, all of these things? And what may be the impact on their business models, their investments, and the services they can support? Some of these questions actually need to be answered in the short term, even if the full technical and commercial results may be part of a 6G era. And there are a few groups of people better equipped to start to address these than the panel I have with me today. So without further delay, let me quickly introduce them and explain the format of the panel that we're about to have. So today we're going to hear from Diego Lopez, Senior Technology Expert at Telefonica, Nicolas Schubert, Solution Line Manager at Thales Alenia Space, Valerio Frascola, who's the Director of Research and Innovation at Intel Labs, Alain Murat, who's head of the Future Wireless Europe Lab in InterDigital, and Malik Sadi, VP of Strategic Technologies at ABI Research. So a great panel lineup. I'll ask each panelist to speak for a few minutes to introduce themselves in more detail and provide some initial thoughts about the topics we're discussing today. After that, I'll lead a debate about various aspects of convergence. While I'll pick on one panelist initially to answer each question, please panelists all feel free to join with your own thoughts and questions wherever you wish. Let's make it free flowing. And we'll keep about 15 minutes at the end for audience Q&A. So please, audience, be thinking about your questions as you listen, and you can enter them in the Q&A box at any stage, and we'll get to as many as we can. So without delay, let me pass on to Diego to start the ball rolling today.
Okay, thank you, Caroline. Well, when thinking about introducing myself, I have been working for the last 10 years with Telefonica, and I joined Telefonica precisely because I wanted to experiment and to make evolve the network infrastructure based on what has become SDN, NFV, etc. And precisely, I have structured a few ideas that I would like to see as the foundation of what I say and the discussion on precisely on these ideas on network convergence in 2 dimensions that I think are important. Can you move on the slide, please? First, this is a diagram that we presented some time ago that what is trying to show how we foresee the convergence of the different segments of the different technologies and And the creation of networks that are only different precisely by the access mechanisms or the devices that are being used. If you see everything is, let's say, it's intentionally cloudy in the sense that you have cloud systems all over the place. The interconnection is based on cloud-like principles. The points of presence, whether local or regional or central, are based on cloud technologies, etc. And even the aggregation phase is considered based on points of presence that are managed by translating the cloud principles for network management. And the only difference is not the last mile, it's even closer than the last mile. Probably we're talking about the last meters, is whether you are using radio, you're using fiber, or you're using any other means to access the network. Basically, and everything is based on this. You have regular infrastructure, you have an homogeneous way of dealing with the life cycle of the different services, and an homogeneous way of managing them. That's the picture of a full converged network that we have already, we were trying to achieve when discussing about 5G, and that we are confident that we will have to wait probably for an additional generation to achieve this level of convergence. If you can move on, please. The other dimension is precisely, let's say, is more than an internal integration, so to say, is precisely the capacity of integrating with the rest of potential applications, and it's precisely the idea that is to make a convergence at the edge. So we allow that the whole edge and the further clouds can work as a single provider already, and we are working on this right now within the GSMA, and we are working as well in our initial 6G projects, is to have a consistent API for all kinds of developers, well, basically for all kinds of users, whether they are developers, whether they are final users. So you are able to build ones or purchase one and run anywhere, and have the warranty that your applications are following you in whatever the deployment style, whether relying on a hyperscaler, relying on your own cloud, etc. Guaranteeing openness at all levels. And at the end is about building a service continuum in which, again, based on the previous architecture of this set of different cloud points of presence in which you can rely on, and at the same time on the capacity of programming the network devices and programming the forwarding elements, and supporting the abstractions that are powerful enough to work, to allow users to employ an homogeneous view of the work, implementing as mechanisms that are as decentralized as possible. Here there is, and it's intentional, there is no mention to AI because it's supposed to be all over the place, and it's supposed to be highly decentralized as well. So building something that from time to time I have compared with a full network system. And at the end, the mechanisms for orchestration end-to-end and application-oriented, and that includes the capacity of the users, again, whatever the users, of having some control of the usage of the network, and of measuring how the network is behaving. And well, with this, I conclude my introduction. That, as I said, is in these two dimensions I wanted to consider.
Thank you so much, Diego. That's fascinating, and I hope we'll come back to some of those points during the discussion. But for now, let me pass on to Nicolas to share his introductory thoughts.
Yeah, thank you very much, Mrs. Caroline. So I'm working with Thales Alenia Space, and started some work and research on the conversions between non-terrestrial network and terrestrial network back 10 years ago. And we tried without success over the different generation, because simply we were working with the wrong method mean, integration means to work together, not separate from each other. And so then we decided to go to 3GPP to to see whether we could work together with the mobile industry in order to see how to integrate a satellite component into the 5G system. And we are now coming to the finalization of the first standard that will support non-terrestrial network in 5G, and that's going to be finalized in June this year. What we have seen is that after all these years of working together, we have now being able to define the functions that implemented in 5G will support both non-terrestrial network and terrestrial network. So this achievement will open new business opportunities, especially for the users which are in need of global coverage or service continuity or even resilience of network. Because we all know that terrestrial network have huge capabilities in terms of performance, while non-terrestrial are maybe a little bit more limited in terms of service rate and so on. But there is this coverage, which is a real challenge for all, because without global coverage, you cannot serve a large portion of population which is beyond cellular coverage. Next slide, please. So this is the vision we have, we are pursuing. So before the 5G, it was more interworking between two independent networks, the satellite and the terrestrial, with some interface, but it was more independently designed network. In the 5G, we have achieved the integration of a satellite component into the 5G system. And as part of 6G, we plan to design a system that will natively support both the terrestrial and the satellite network components to address a set of common goals. Next slide. The next slide is actually saying that the NTN is addressing two kind of market segments. The first is the consumers directly with handset in order to provide them with service continuity and digital and reducing the digital divide. Whereas also we are targeting the vertical players of all this industry with a different kind of terminals, but also handset. And that's enabled with the standard that's going to be released next month. And what we see as in the perspective of 6G is to enhance the NTN with new services like the ultra reliable low latency communication service, which is not addressed in 5G, thanks to lower latency capabilities. New capabilities like the GNSS-free operation. GNSS refers to global navigation satellite system, so GPS and Galileo. And also higher performance, as we will see, will be provided. But one thing which is very important is the reduced footprint, especially energy spectrum, but also carbon emission. So these are the four axes on which the industry will work in order to enhance NTN in the 6G compared to 5G. Next slide. So here we are highlighting a few KPIs that the industry is looking at, which is obviously to increase the bandwidth. As usual, people are greedy and always greedy and they want more. latency is something we need to work on because the people are naturally frustrated and they are not wanting to wait any further the download of web pages. So obviously the satellite industry has to work on that by considering lower orbit constellation. We should be able to also address light indoor in-car environment and reduce or increase the accuracy of positioning services in outdoor conditions. So these are 4 axes for KPIs, and in order to achieve that, we have here on the right hand side a number of technologies or concepts that should be explored in the research and in the standard to achieve those KPIs that I've mentioned about. So to sum up, 5G NTN is already providing a lot of services and that meets the needs, but with 6G we'll go one step further in terms of performance and KPIs and so on. But the same market will be addressed, and that's because we see the strong interest from the user community to embrace a global standard as opposed to legacy systems which are more proprietary and leads to network or technology lock that users wants to go away from. And besides, through the adoption of standardized technology, it's easier to support service continuity, handover, mobility across the terrestrial and the non-terrestrial network, as well as multi-connectivity and so on. So that's it. My next slide, you just see my contact details if you're interested. Thank you.
Thank you very much, Nicola. It's fascinating stuff, the whole idea of these sort of edge clouds in the sky and the whole architecture around non-terrestrial 6G is so interesting. We'll certainly come back to some of these points. But for now, I'm going to pass on to Valerio, please.
Good morning, good afternoon, everyone. I hope you can hear and see me well. So I have one slide. I wanted to keep it very short to give room for more discussion. And I took the opportunity of being part of a European funded project called CIFIS-Home that exactly goes into the direction of convergence of several key ingredients that are part of 5G, and they will even be more part of 6G. And so I thought a good idea to take the opportunity to briefly talk about the, let's say, enabling technologies that make this project a reality and will provide interesting contribution to the European and international ecosystem on research, but also on industry application, and then to elaborate briefly on the balance that you see. So let me start saying that my role in Intel is I'm responsible Europe-wide for all the business unit for funded projects. So actually, I have kind of a natural attitude when I'm asked to have a talk or to discuss about a topic to bring in a funded project. So bear with me for that. It's my quirk. All right. So the CIFIS-Home stands for Secure, Interoperable, Full-Stack Internet of Things for Smart Home, and already the name tells a lot. Actually, you see that it's a 3 years funded project and is going to be building, because it's a midterm now, it will end in 1.5 years from now, some very interesting ingredients. Let me start going through them. These ingredients, by the way, are meant for a very, let's say, impacting vertical, which is the smart home or smart city. As you know, by 2030, more than 75% of the people in the world will be living in a city. So whatever we manage to do there as a technology deployment or as in impacting new technology enablers, will have the biggest possible impact on the majority of the people and therefore of the society on Earth. And this project actually takes AI as one of the ingredients. So it is AI-fying part of the way that equipment are dealt within a smart home environment, or if you want domotic. It has a big chunk of edge activity. It deals a lot with security, because when we want to deploy and digitalize our world and our home, of course, security comes to the foreground. We don't want anyone else to know what we're going inside our home, because we stacked cameras everywhere. Interoperability, and that relates to standard, and of course, standardization of what 6G will be. As you know, it will start in 2025 around the first 6G standards, real work. Interoperability between different standards and different equipment in different layers of the different protocol stacks that are used in the world is a key thing to achieve, still outstanding. Resiliency of system, it's also something that will come more and more in the foreground for all of us. Disregarding the vertical, we take care of the resiliency of AI-driven X could be an auto, could be a home, could be a network, could be a satellite, whatever you want, will be very important to trust the integration and the insertion of new technology in the daily life of normal people, not technologists like us. Open standards, so not only standard, but also open standard is one of the key things that we should all look at when we glimpse at 6G. And the last 2 points, which are probably the most important for the environment and for the green path that we are all took. You might see on the right side that it's all green, the picture coming from the project, because we lean a lot on low energy equipment. Of course, we are working in an IoT related and edge related, so low energy is intrinsic to several devices, but it's also very important to deliver services to the best way and to the best format to final users. And overall reduction of CO2 emission, this is a system parameter that we should all have in mind when dealing with new technology enablers. With that, I end my very short presentation. As I said, we'll be happy to discuss about that further in the panel. Thank you.
Thanks so much, Valerio. Yes, and great to pull the focus perhaps onto real-world use cases and how this convergence actually may affect us in our daily lives. Definitely, we'll come back to some of those issues. Now, I'd like to ask Alan to say a few words, please.
All right. Thank you, Caroline. So if you move to the next slide, please. Yeah. So maybe just introduce myself. Alain Mourad. I head a team based in London with focus on the evolution of 5G to 6G. So what we do here in London in the team is pretty much research and innovation activities. And the way we do our research and innovation is by collaborating with a lot of the partners and the instruments available to us in the European ecosystem. So pretty much, if you like, similar to what Valerio position himself, I would position myself here in the team in London. I mean, the topic on convergence is very close to my heart. I remember actually, Caroline and team, I was at one of the WWRF meetings, I think 2018 or so, a 5G huddle in Japan. And I was sitting on that panel with colleagues like Bernard Barani from the Commission and Professor Ezed Derweze from UCL London and a few others. And this is actually when we started really, positioning 6G as a network of technology convergence. And this idea continued internally with our company, InterDigital. And recently, we worked together with Malik from ABI Research, who's on the line today, where we supported the white paper very much actually, at the heart of this topic, seeing 6G as a network of technology convergence. So this is a bit, if you like, my connection with the topic on convergence, but also the connection of my company with the topic. Now, obviously, there are multiple aspects actually of technology convergence when it comes to 6G, right? And to be able actually to spell out these convergence points, I thought that there is no better actually than to go and look on the 6G vision that is emerging through the consensus building that's happening at the ITU, so the International Telecommunication Union. So as you are aware, ITU has already started its activity around building a global vision on 6G, but also technology trends. And so the vision as it is emerging is pointing in the direction of immersive, inclusive, sustainable connectivity that is augmented with intelligence and sensing. So it's a lot of keywords, but actually each of these keywords actually hides behind it an element of convergence. So with the 6G, obviously I kind of elected to have 6 points of convergence to kind of shed some lights on. The first being the convergence between computing and communication. And we already had both Diego and Valerio and Nicolas partially highlighting the story of edge and the convergence with the computing substrate, right? So edge, the story of edge and communication and cloud and communication has already started. I mean, it doesn't need 6G, if you like, for it to start. It has already started with us, as you're pretty much aware. But then 6G will take that convergence to a very next level, actually. With more disaggregation in the network, with much more demand on the latency side, the core network moving to cloud native. So there's going to be another dimension of how computing and communications will support each other and will converge with each other, actually. So this is the first dimension. So pretty much I see it actually, quite an analogy between the computing substrate that goes, if you like, from the fog device, the small device, fog computing device, to the edge node, to the cloud. So this there is a parallel to this in the connectivity substrate, which actually the end user device, so the user equipment, if you like, the radio access network and the core. So these two parallels will come together pretty much through that computing and communication convergence in 6G. The second point of convergence is around sensing and communication. And again, pretty much in the same kind of approach that Nicolas presented on how we see terrestrial and non-terrestrial kind of interworking already prior to 5G, and then coming together, if you like, through an integrated approach into 5G and 5G Advanced, and then fusing together, if you like, or unified together as we contemplate 6G and 2030 timeline. So that same actually roadmap applies also to the sensing and communication. So sensing and comms, they are already here with us, even before 5G. But then there is already actually significant work on trying to integrate sensing and communication, and there is no better evidence on this in the industry than looking at what's happening in the IEEE, in particular the 802.11bf activity, right, where we see this already unfolding there. And then as we go further into 6G, so we see the sensing and the comms really coming together into one system, providing that capability of sensing, positioning, and the likes, alongside the communication capability. So the third convergence point is pretty much around AI/ML, as Diego clearly said. AI/ML is going to be here, native, if you like, within 6G, and it's already with us. Actually, it's already with us. Maybe not in all the stack layers of the OZ stack, but it's already with us on the network management side, and we see this actually AI/ML supporting even more communication and the communication stack, even maybe to the lower layers as we go forward. And there's also another key point here that actually AI/ML, especially with the federated learning and the distributed learning that we envisage for AI/ML going forward, they will require communication actually. So the communication will be at the service of AI/ML distributed roadmap. The fourth point, which may not be as so straightforward, is a convergence between visual technology and communication. And this is pretty much linking to the keyword immersive. So many of the use cases that are contemplated actually for 6G, so they build around the immersiveness, if you like, the metaverse of things and the haptics and the XR and the likes. And then for a proper support, if you like, of all these use cases, there must be a proper marriage drawing on the visual technology coming together with the communication technology. And also, I think a key point here that most of these network nodes and equipment, user equipment, as you appreciate, they are coming with significant visual equipment with them, like cameras and things like that. So this will help also, will take another dimension by providing help to the communication stack to improve going forward. The fifth convergence point, I don't think I need to elaborate on that point. Nicolas already provided very good coverage on that one, non-terrestrial and terrestrial. And the last convergence point here I would like to draw attention to is really between the optical technology space and the wireless or the radio. And why is that? Is in particular because of the aspiration for radio to go above 100 gigahertz. So to take the next to take it to the next level in terms of hundreds of gigabit of per second of throughputs, right, and hundreds of gigahertz of radio frequencies. So analogy and similarity and cooperation and convergence between optical and wireless becomes like a must. So with this, I will leave you with these thoughts, and I'll be looking forward to the discussion with the panel.
Thank you so much, Alain. That's really fascinating. Actually sets a really nice framework for some of the topics that we'll be discussing shortly. But last but not least, before we go into that panel debate, can I ask Malik to just say a few words as well?
Yeah. Oh, hi, everybody, and thank you, Caroline. Actually, I don't have any slides to share with you, but what I'm going to share in the next 5 minutes will be a vision of 6G captured by talking, to a number of our contacts and partners within the value chain. I'm Malik Sadzi, Head of Technology Innovation at ABI Research, a market intelligence company specialized on identifying new technologies and business models likely to shape our future. So we perceive 6G as a key technology pillar that has the potential to consolidate innovations coming from multiple industries into a single network, into a really single ecosystem. So early this year, ABI Research published a white paper in collaboration with InterDigital. I think Alan referred to that white paper. And in that paper, we share our vision on 6G as the network of technology convergence. And in that paper, we identified 3 types of convergence 6G will support, namely the communication and computing convergence, refers to as 6G native intelligence in the paper. So Alan touched base on that, but I will elaborate a little bit on that later on. The convergence of access networks combining cellular, nomadic and satellite technologies to enable ubiquitous coverage and service continuities anywhere and anytime. And again, various panelists already touched base on that, but I will elaborate a bit on how that vision should shape. And finally, the convergence between the virtual and the physical spaces. And as the industry is cruising its way towards, the metaverse. So let me start probably on the evolution of cellular network towards 6G. And that evolution should not be just about simple evolution toward high performance and high reliability. It should be more an access agnostic network aiming to guarantee seamless service delivery wherever we are in the globe and regardless of the nature of the access network used, either that be licensed or unlicensed radio spectrum, satellite communication, or short range connectivity. So basically all that should be abstracted, to the end user and basically enable, service continuity and ubiquitousness wherever you are in the world. Another type of convergence the industry is talking about is computing and telecoms convergence. And that's something very close to my heart. And that is driven by the emergence of new enterprise and consumer applications, such as AR, VR, super sensing network, edge computing, collaborative services, holograms, and localized content at the edge. All those applications and use cases will require more distributed computing and intelligence across every single node of the infrastructure, from the cloud to the far edge of the network. So this development will imminently require the industry to consider computing as a native part of the 6G network infrastructure, meaning the network should also accommodate computing and intelligence planes natively, in addition to existing telecommunication control and user planes. This is to ensure end-to-end orchestration of workload across both communication and computing domain. This type of convergence will be enabled by the ongoing software-hardware decoupling we are already seeing, the ongoing virtualization of telecoms, IT, and OT functions, the commoditization of processing technologies, and by software convergence, basically abstracting the complexity of computing and a network to the end developer, to let them focus on what they are here for and what they are best as, building innovation and using their imagination to create applications that will improve our lifestyle and contribute to our economic growth. All those elements will make 6G more software-centric network, meaning developers again will be able to create inclusive, all-inclusive and customer interfacing applications where computing and network complexity are abstracted. And under this vision, developers can fully leverage the network capabilities to build, the mission-critical applications they are required to build. And those applications obviously rely heavily on the network connectivity. The third type of convergence we have identified is the ability for the network to accommodate new wave of digital innovations, notably the build-up toward the metaverse. You should see the metaverse as a confluence of interconnected open platform, bringing the virtual world and the physical world spaces together under a single technology ecosystem. These concepts can help multiple industries to reduce operation expenditure, align with their goals of reducing CO2 emissions through implementing automated infrastructure and reducing the costs related to the unnecessary costs related to physical trials and proof of concepts. So all those type of conversions should be integrated natively to the 6G infrastructure. From this perspective, industry players across multiple supply chains should imminently collaborate to build for this vision of 6G as the network of technology convergence. Right, so over to you, Caroline.
Thanks so much, Malik. Really interesting thoughts as always. Thanks to everyone for setting the scene really well. And there's already so much that we could follow up with discussion, but I'll start with a few questions. Pardon me. As I said, I'll initially direct each question to an individual panelist, but after that, if anybody else wants to offer some more thoughts as follow-up, please just jump in as you wish. I'd like to sort of bring this perhaps back down to earth. We've talked about some really interesting architectures here. But as I said in my introductory few words, we have talked about convergence a lot before in 4G, in 5G, and particularly related to fixed mobile and cellular Wi-Fi. But real world adoption at the network level has really been quite limited. And I wonder what the panel thinks about why. Is this because there hasn't really been a need for it? Has it been too technically complicated? Are there conflicts of interest between the different ecosystems? I mean, there are many reasons we could think of why convergence hasn't progressed as far as it might have done already. So could I start with Diego to perhaps give us a few thoughts on that?
Well, I believe that basically what has influenced more precisely the lack of convergence in the past has been the fact that the technologies or the base technologies were quite disjoint. And whenever there was an evolution, I mean, you have an evolution of the technology on the one hand and an evolution, I mean, that were not necessarily well aligned with the economic cycles. I mean, the time for in which well, our accounting departments were allowing us to make further investments. Precisely what we have right now is two forces that I think would influence this convergence. First is the common technology substrate. I mean, the basic infrastructure right now that you can think for mobile, fixed, whatever networks is the same. You're based on SDN, you're based on software networks in general, regular infrastructures, with some, for sure, if you have to deal with the fiber, you have to deal with the fiber. If you have to deal with the radio, you have to deal with the radio. But precisely these disaggregated approaches will help in this. So in the future, when there are the needs for investments on infrastructures, etc., in principle, they should be consistent and favor this convergence. On the other hand, I think that precisely the pressure on the side of the demand, in terms of that more and more convergence of the technologies and the way in which you work, and of a seamless use of the network services will force operators and will force technology providers precisely to provide these converged solutions as well. So I believe, well, probably this is the right one, even being the sixth one. So
yes, six times a charm.
Exactly, the charm, yeah.
Exactly. Anyone else like to comment on why this is perhaps the tipping point for convergence?
Yeah. So if I may jump in, Caroline. Well, before talking about, the convergence and the failure of convergence, in previous generation, convergence is a type of innovation, and innovation is a journey. It's not like something that could happen at a point of time. And that journey you need to build for it, to create, an appetite for use cases, and an appetite, for applications that could use that. Now you are talking, obviously, about, the failure of convergence even as early as 3G with universal mobile access, voice continuity and stuff. But those applications have created a mindset of convergence. But then that convergence has evolved throughout generation, including with 4G, introducing, the LLA, which is basically the aggregation of Wi-Fi with cellular. And again, compelling use cases were not there. And then further evolution has came with things like side link and so on with 5G. But all those processes are very big stones in the build-up for that convergence. So now, we truly believe, that the time has come, to collect all those fruits, from the introduction of 6G, and 6G will, enable, that to happen.
If I can chime in, Caroline.
Oh, Alan and then Nikolai.
Yeah, brilliant. Yeah, honestly, I don't think there is a failure of convergence. Pretty much like I think Diego put it, if you take the transport network, if you take the all these parts of the network and domains of the network may be accepted of the access, right, at the very last mile, right? There is already convergence that's happening there, right? Even from the time of 4G and maybe even 3.5G. So where convergence did not really materialize, if you like, so tangibly, and is pretty much in the last mile, if you like, or quarter of a mile. So why is it the time now to hope and see 6G bringing that convergence to the last mile? Is because pretty much this last mile is centered around use cases in the home, the residential, the private networks, and the smart factories. So all these kind of use cases, right, that would benefit, if you like, from a significant upgrade in let's say the throughput and the latency experience and all the stuff. So these would require now a proper convergence between the two. And I think there is no better example in my mind now than to bring to the table here the recent announcement around, the 5G standalone deployment, pretty much taken as, the enabler, right, for convergence between the broadband coming to the last quarter of a mile, complemented with a proper millimeter wave, to support the very last quarter of a mile, and all these immersive experiences at home or in any private setup, right? So this is an example of why we believe convergence will be in 6G, because if you take it to the standalone of 5G millimeter wave, finding its niche today into complementing the broadband infrastructure. So this is where we are taking it forward as we contemplate 6G.
Right, and Nicola.
Yes, thank you. Indeed, convergence is already happening now, because it's driven very much by the user community, which is calling for it. If you look in 3GPP, the number of user community that are now getting involved, it's huge. Over the past 4 years, basically all kind of user community are now being active in order to drive the specification for the 5G advanced and the future 6G, because they want to adopt this standardized technology, and they are calling for the possibility to make use of a converged network, convergence at all level, as was explained by the panelists before. So it is something which is inevitable and will be phase, I would say, developed further during the next years. So it starts already with 5G advanced, but it's going to develop further in the context of 6G. Thank you. There was one thing that maybe that prevent this convergence is still the establishment of good business model that allows a win-win between the stakeholders of the different technologies involved. That's the main break. But the users are willing to get that. So more and more the service providers are forced to find the suitable business case that will allow this implementation of conversions. Thank you. Sorry if
I want to come back to some of those points, but Valerio, let's hear your views on this first.
Thank you. Yeah, so some of the points I had have already been picked by my colleague. I just wanted to mention two things that have not yet been, you need to have a reason to create convergence of different technologies, and these reasons needs to come from the market, right? So if there is someone that benefits and that can make business out of it, it will come later or sooner or later. So that has not been the case so far, because we are adding features each new technology of the telecommunication system we are putting on the table, right? So I remember the good old days of 3G, where we were working on, oh, the interworking 2G, 3G is a pain, doesn't work, we have to expand the network, double it, all this stuff. The same with the 3G, the same with 4G. And now we have 2G, 3G, 4G, and 5G interoperability that needs to happen everywhere, with different bands in different areas of the world, because there is a reason. People are traveling, and I want to have a call that is stable if I'm in UK, in Birmania, in Italy, or in South Africa, right? At the same time, I don't want to be bothered by a specificity of the location where I'm doing my business. 20 years ago, it was not like that. So actually, the need for new features, a new capability of the network creates the need for convergence. And second, you also need to take care of the legacy systems that are already there. And you cannot simply come with a new system that is much better than before if the old one cannot be used at the same time in parallel, overlapping, or let's say in a hierarchical manner. It depends with the new things that you're introducing. And finally, this is a topic that Intel, of course, is very keen on, the softwareization, let me say, of the different building blocks of a telecommunication architecture is coming more to the foreground. And if you let's say abstract yourself from the hardware and the firmware domain, you have more flexibility, and you become by definition more interoperable, because you need just to have a new software release. You don't have to change any equipment. You just need to have on the air a new piece of software developed to your devices. So these are the three things I wanted to add. Thank you.
Thanks so much, Valerio. And I'd like to sort of follow on from some of that discussion and think about what really are the drivers. We've heard a lot of interesting points there about the sort of user demand for convergence, but there still needs to be an economic case for the operators, assuming the operators are still going to be the major investors in building out these new networks, as they have been in 5G. But also, I think a lot of the work that bodies like ITU are doing are within the context of much broader social economic benefits for society and for industry around the world. So, Alain, maybe I can start with you, because I think it has been a context for a lot of the projects that you've been involved in. What do you think are the pressing sort of socio-economic drivers, but also are those can those translate into a good business case for operators? Yeah,
fantastic. Thank you, Caroline. I think it's to be honest, it's a tough question, right? It's really at the intersection, of what the ITU is doing, what the market, forces are, right? To be honest. So I'll begin with to again, shed some light on why convergence hasn't happened so far. So that might actually give us a bit of an idea, and why should we see it happening now, with what agenda actually the ITU seems to be pushing. So again, I mean, sorry, I got actually clicked on the wrong button with the Teams call. So again, I mean, if you take actually, scenarios like the home or in the factory or in the private network, right? Up until today, Wi-Fi is still with us as a main incumbent, right? And there hasn't been a significant, if you like, penetration of cellular connectivity, be it 4G or even 5G today, to kind of shake up a bit, if you like, the Wi-Fi model. Right, and the Wi-Fi model is very important because it's cheap, right? So again, the cost is key here, and it was deemed, enough to support the needs of the user, right? So if I can actually get with the fiber to my, village in the UK to ask to one point in the village, right, and then with the copper, I get to the home with a significant, throughput, and I have Wi-Fi at home to support me. Why should I need actually to look for something else, right? So there is an element of cost and the user need and the and the services the user actually has got to benefit out of a new technology, right? And at the same time, also the challenges for a technology like 4G to make it into to shake up, if you like, the let's say the at home or the residential kind of network. Only as an example, so I'm taking the residential just as an example to get the ideas crystal clear, right? Now that there are new use cases, right, that cannot be supported by the current Wi-Fi, that would require a significant change of the infrastructure that's reached in the last mile, if you like. We talk of digital twinning of real proper XR, and the reason, for example, XR did not pick up is because of the challenges with the incumbent technology at home or in the infrastructure. So now that these technologies are mature and they are really in need to make a business case and to hit the market, right? So we start to see a rethinking, if you like, of the convergence, of trying to bring more advanced technology to replace the incumbent technology. But for that new technology to replace sustainably the incumbent technology, it has to come at a very low cost. It must be actually motivated from a business point of view as well, right? So that's, if you like, the business landscape somehow around the convergence. Now, there's obviously also societal, right, drivers as well, because obviously the green agendas, the fact that we need to bring power consumption to new levels, CO emissions, and all that stuff. So this can only happen, right, through by looking at the holistic system. We cannot actually just say, look, we need to reduce by 50% or 60% the power consumption in the radio access network of an infrastructure, right? You need to look at it in the same context as with the computing fabric available to the network, like, what's the power consumption of these edge servers, of the cloud, of the devices, of the fiber, the transport network. So it must really be like, a holistic approach when it comes to assessing, if you like, the societal requirements. And when people start to look at it in a holistic way, that sparks some ideas on why there must be, or the best way to go about it and really optimize these societal requirements, if I may call them this way. They must come through a proper thought through convergence across all these technologies, right? Because if we keep these technologies in silos, we will never be able in a position to meet the requirements or even exceed the requirements, the societal requirements. So I'll just leave it with you at this level, right? So what would be driving, if you like, the next level of convergence?
Great, some really interesting thoughts. Valerio, I think you had your hand up.
Thank you. Yeah, I use the nice feature of raise hand. One thing to add to the palette of topics that Alain managed to put on the table in 2 minutes, it's very interesting, and many we might need to have a panel, each one of them, probably. Just one thing. So you were asking for the pressing drivers. That to me depends very much on the vertical that you are targeting to look at, right? So the needs that you have at home in a smart home or smart city are different to the one that you have in a smart industry. And I come answering one of the questions that I've seen in the Q&A. So I merged the answer to your question and the question that came to the QA. So basically, for instance, in an industrial environment, you have the need for things to work smooth, because losing seconds and even minutes is a disaster from the economic point of view. If you are at home and you lose some second of your connection, doesn't matter, because there is nothing that is so crucial from the economic point of view that you do at home that you can bear with that, right? So reliability. In an industrial environment, you have a huge need for reliability. You have also redundancy. Everyone expects the redundancy in being industrial environments, because you know that without them, you cannot deliver the service that you are supposed to in the contract design. At home, you don't want to have two boxes just to have a better connection, right? At home, you just want to not see any equipment. Ideally, they are merged into the wall and you're happy. So redundancy at home is nothing that one would accept. So it depends on the vertical, it depends on the sector, which are the driving things that people would accept, would pay for, and would need as well. So, you have different needs. If you're working in an autonomous driving, of course, redundancy, I want to be more than 100%, if it were possible, secure that my auto is not crashing if my child or myself is driving, right? So I would accept whatever redundancy there or whatever additional cost in order to be safe home. So it depends very much on the vertical. That was the message, and also an answer to the question that I got. Thank you.
Great. Thank you, Valerio. When we're thinking about these objectives, and clearly, as we've touched on here, there are lots of social, economic, telco-specific sort of drivers for convergence. And in theory, we would like to see all the different types of convergence that our panelists have outlined earlier in the session. But do you think there's one particular area of convergence that is more critical than the others to deliver on all these objectives? Is there something that we really can't live without in the 6G era? Maybe I'll start with Nicolas on this, who may make a case for NTN convergence, but obviously it's not just networks, it's also convergence with cloud and visual technology and the things that Alain mapped out. But you know, if we had to choose one, which one can we not live without, Nicolas, do you think?
It's maybe I think already there is a convergence between wireless and mobile, and that's something which it's already implemented and widely adopted. Obviously, I will advocate for the convergence between non-terrestrial and terrestrial, because in these, as Valerio explained, people are traveling. This is the case for consumer, but it's also the case for verticals. And today, when you look at the travelers, they want to have a seamless experience across the different coverage that they're encountering. And so currently they are trying to use some proprietary scheme to do some kind of mobility between different legacy systems that will somehow provide a service wherever they are going. And we can see in the aeronautic market, for instance, you have the plane that goes from one place to another and will hop between different legacy systems that are difficult to interoperate between themselves. So the mobility is not smooth. We are trying to solve that. Besides, there are some companies that with providing services on vessels, and they would like to have a smooth transition between the shore coverage and to the deep sea coverage, and that's it's somehow done with some proprietary mechanism, but it doesn't work very well, and that's where we want to improve that in order to. So in general, people would like to have not detect service change when they change from one coverage provided by one technology to another coverage by another technology. So this is the conversion that we are trying. Obviously, I'm working on the coverage because that's the added value of satellite, but people are not even between Wi-Fi and the cellular, they would like to have this kind of service continuity. So yeah, service continuity is one aspect.
Absolutely.
I think it's very important. Yeah.
Sometimes in our 5G and 6G conversations, we sort of we focus so much on capacity and latency, and sometimes we forget that so many of the applications we talk about, particularly anything that's vehicular, does require absolute ubiquitous coverage, which has been a dream for our industry, not something that we've ever achieved so far. Diego, I think you.
Yeah, I wanted to mention that from a pure telco perspective, precisely many of the things that Alain and Valerio and Nicolas has been mentioned about coverage and outreach and addressing, satisfying customers' demands and not inventing things that are not necessarily needed, have to do with something that is equally important. I mean, the demand is growing, even if we're talking about the same, maintaining the same or providing the same. in a widest coverage to more devices, to a more dense deployment, etc. And that threatens something that is essential. It is the sustainability of the whole environment. And precisely this is, in my view, this is the main economic driven, is that even just to keep things as they are now, but at a much wider coverage and much dense coverage and much deeper in the sense of the number of linked devices, etc. That would require precisely to make this viable in terms of economically viable, would be essential precisely to address this convergence. And it would be basically, this is not something that is about making more money, it's just about surviving, if you think about it.
Absolutely, yes. Great, thank you. I mean, I'd like to turn to, oh, sorry, Valerio, you wanted to add a comment, please do that. And then I'm going to turn to you anyway for our next question. So.
Okay, yeah, a different pitch. In my opinion, from the technology perspective, what would be really needed to make a huge step forward would be the AIification of the way that we do everything. Meaning that, you know, there are several technology enablers that can give us 1 or 2x, ideally, let's say in 10 years, improvement of some KPI, but the game changer to me is the smooth integration of AI, not as a service that you ask to do some things, but you know, by construction, AI-based system, so that each layer, each thing that you're doing as an AI capability, and the AI can be hierarchical, scalable in order to make things automatically smooth and give the opportunity to take the best decision in the specific, let's say, vertical or moment in the day, in the area of the world, using different technology, fiber, satellites, cellular, wired, depending on where we are. So the biggest leap that we will experience, let's say by 2030, that's the mindset we have, right? When we will see 6G deployed, 2027 onwards, it will be a big difference if we will manage as a community to think how to have AI really deployed in a way to make a difference. And it means not as a service you call from some layer, but embedded in each layer. So let's say AI by construction, that will really make a big difference. That was what I wanted to add. Thank you.
Great. And Alan and Nicola, to follow up.
I'll be brief. I mean, certainly agree with Valerio, but I would like actually to take it from a different perspective, right? So I would say it would be fantastic if 6G can bring a proper convergence between comms and visual technology, right? And simply, I take the end user perspective, right? So we are looking for the wow. What's the next level of experience actually would like to appreciate as users, end users, or if you like, you know, even verticals like factory owners and things like that. And as you know, AR and VR, they have been with us for you know, quite a long while. 4G couldn't deliver. 5G is at the very, very, very beginning of delivering, right? I think, as we say, a third time is lucky. So hopefully now with 6G, we should be able to see that there is a proper enablement, if you like, of all that augmented reality experience where users can appreciate, you know, in different setups in the high street, retail shopping, at the airport, at home, the gaming and all this stuff. And for this to happen, we need that convergence to be here with us.
Nicola.
I wanted to add, okay, we are talking about artificial intelligence, and so it's a huge increase of the software part with respect to the hardware, and that's going to bring a lot of complexity and will lead with very, very serious challenge in terms of security. So security is going to be a key enabler for all this convergence. That's
yes, that's a very good point, which probably certainly merits a whole webinar and discussion of its own. But yes, absolutely. Valerio, I wanted to point to you a question about the components, the cost and the complexity of implementing all these multiple technologies. In the end, they've all got to be part of equipment and devices that are affordable and deployable. And I know you're in Intel Labs, but I think in the end, what's done in Intel Labs filters through to the whole component value chain because of the influence of the company. So I wonder if you have any thoughts about how we can address the challenges of achieving converged networks and particularly converged devices without adding impossible cost to the business model.
Well, that's the question, right? I think that this is a question we all have. First, one clarification from my side. Intel Labs is the division of Intel that works with research. That's why I say Intel Labs and not simply Intel. So we are 800, almost 900 people worldwide dealing with all sorts of things. So we kind of have the vision of what's going on next between 3 and 8 years in front of us. So to your question, what would make possible from the economic point of view to have this convergence happen? Have I summarized the question right? Yes.
Yes, in terms of the cost of integrating everything in something that that we can use, that we can put in our pockets. Or...
Yeah, I'm sorry to repeat myself, but the cost depends on the use case you have in mind, right? And on the vertical you target. So as I said before, for industry, you would accept cost at a certain level. For home, you won't accept all the same cost because, of course, you have to do it yourself. Whereas for industry, it's a company that pays the bill. So there are new challenges that we have been witnessing in these last 2 years and a half, that are pandemics and wars coming back big time to the foreground to all of us. And that will make a big difference in the way that we are used to deal with sources of raw material, but also of equipment. Because as you know, most of the equipment is built in Far East, and we are waiting for ships to come at their speed through the sea to reach our assembly or packaging lines in Dar es Salaam in Malaysia. But from Malaysia, we have to ship everywhere in the world. So, and therefore, that will be probably one of the biggest unknown that we can't solve, and there is no technology that can help us. Of course, there are approaches and plan B that we can have in mind to reduce the cost of, for instance, the port of Shanghai being stopped for 3 weeks due to the next pandemic. But this is nothing that we can really do anything about. So the message is we would have to rethink the way that we have the chain of small pieces coming one from the other that will compose a final product. You might know, sorry to say that, but Intel is going to build a new chip in Europe. It was a big announcement. And you see that other countries are doing the same. So they're trying to get closer to the source of chips in order to be more independent from the chain problem that are probably being more and more evident in the years to come. So actually, there are movements from big governments worldwide to ensure the capability to have their own chip locally built, So this is a trend that we'll see more and more. European Union started because we are one of the most populated area, one of the most rich area in the world we can afford, but I would expect the same to come from India. China has it already, of course, and the US is doubling up its own capability of building chips as well. So why I'm saying this? Because this is tightly linked with the cost. So, having something that cost 10 cents 2 years ago or $1 now would blow up completely the value chain of everything. And actually, the final user will see a big change in what he or she gets for the money that he or she spends. And this is nothing that we can control, which I would say is very good for us because we are researchers and we are technicians. We will be facing new challenges that we didn't plan at all 2 years ago. So for us, let me say very bluntly, from the research point of view, it's a thrilling new world that is in front of us, which is a world that has no certainty. In previous time, I was certain that if I have a contract with Chinese or Taiwanese company, they will ship in 6 to 8 weeks. Now that world has disappeared. So, or at least it's not as sure as before. So the way that we will manage to address this new challenge will make a difference on the final user, how much they will be charged with unbearable costs. So I made a long story, but to make it short is we are witnessing new challenges. It's up to us now to produce something that can cope with those challenges in the way to reduce at minimum the bear on the final users, because actually if they won't buy our product anymore, we will be out of business.
Absolutely. Great. Well, I want to move to some of the audience questions now, because we have some really interesting ones coming in. And I'd like to start, bring you in, Malik, if I may, because the audience is, one of the audience members has asked a question which is in line with something I wanted to discuss in this panel anyway, which is looking at all the stakeholders involved. So we're looking at how the technologies converge and what the use case demands are, and this is all really interesting. But obviously, the more aspects of convergence there are, the more stakeholders there are, and the more sectors of industry need to manage to work together. So, Malik, I know this is a question that would take hours to answer, but perhaps a few introductory thoughts on: is there a common vision, and do you think that various sectors, because after all, we're talking the cloud, we're talking NTN, we're talking telco, and many others, is there common vision, and how do you envisage the whole value chain changing as we move towards these converged networks, in terms of working together, also in terms of co-investing? Because going back to the point made earlier, you know, are telcos going to build all of this themselves? Again, I suspect not. Oh, you're on mute, Alan.
Thank you, Caroline. This is $1 billion question, yes. and a difficult one to answer at this early stage of the industry development. We are still 10 years away, you know, from 6G. But to answer explicitly to your one of, you know, or part of your question about, you know, is there any common vision? Definitely yes. That is happening, you know, and we are hearing that, you know, across the board and across, you know, players, we are industry players we are talking to. So they are all trying to build a mix of expertise, either that's being cellular, Wi-Fi, satellite, computing expertise, and they are trying to diversify their investments to find themselves in good position to address, you know, 6G opportunities. We are seeing, for example, hyperscaler trying to build expertise across variety of connectivity solutions, not just cellular, on Wi-Fi and even satellite. And equally, you can see, you know, that infra suppliers are also heavily involved in building expertise in computing and distributed intelligence, and operators are interested also in those environments. That movement started already, you know, that mindset started already with 5G, and it will likely and imminently evolve as we cruise our way towards 6G. But one thing, you know, I would say, you know, I think, you know, the heavy burden in terms of building, you know, 6G will lay in the chipset creation, right? So that's where, you know, the heavy burden needs to be unlocked. And I think, you know, chipset suppliers are doing very good job right now in diversifying and promoting, you know, that decoupling between, you know, the hardware and software to enable more converged software creation. So they are trying hard to integrate, you know, their chipsets, whatever nature of that chipset, FPGA or CPU or accelerators, into single block and create an abstraction layers, so it is easy for software developers, you know, to create those applications, wonderful applications that are abstracting the complexity of, you know, the underlying, you know, hardware technologies. And that is really, that mindset is inseminating across the supply chain, and for me is fundamental, let's say, element pointing that 6G could be the G everybody is waiting for, the G that will address both consumer and enterprise opportunities.
Great, thanks. Thank you very much, Malik. Another question that has come in, and this is definitely one to address to Nicola, I think, which is, we're talking obviously about integration of non-terrestrial with cellular and terrestrial networks. But is that always necessary? Do they need to be integrated, or are there also cases emerging for the NTN provider being the lone provider of services?
Yes. Well, indeed, it's always, I mean, the satellite industry has already provided internet access in some rural areas and on board some vessels and so on. So it's already happening. However, when and they are providing like internet access through some access point that will provide with the Wi-Fi the service to end user devices. But those end user devices are more and more handset, laptop, and tablet. And those three end user devices are moving around. They are mobile. And so they implement indeed the Wi-Fi technology, but also the mobile technology more and more. And therefore, it is important to achieve the integration of NTN into the mobile systems, because the end user devices are mobile by nature. But of course, you know, there are some existing systems that are being deployed, and one of them is very well known. It's the SpaceX program that provides connectivity to some access point. And these access points are a Wi-Fi for end user in a rural area, and they're not connected at all with the 5G and so on. But this is okay. They are addressing a very specific use case, which is rural connectivity, and as well as connectivity on board vessels and so on. But my thinking is that in the future, given that the end user devices are mobile by nature, integration with mobile is necessary. Thank you.
Great, thank you, Nicola. There are quite a lot of questions coming in that relate to IP, and sort of summarising them, I suppose. Will IP, Internet Protocol, be adequate for what we're talking about here? I mean, obviously there are already projects to look beyond that, next generation protocol and so on, but wonder what any of the panelists think about the evolution of IP. I mean, at just a very specific level, will everything be IPv6, or do we just need to look way beyond that to whole new protocols to make these architectures work in reality? Don't know who would like. Diego, would you like to have a go at that one?
Oh, well, yeah, I believe that IPv6 is, I mean, IPv6 and as you said before, or other next generation protocols probably will have a key role to play. But I'm not sure if that's by definition all networks, when we arrive to 6G, all networks are going to be IPv6 for a simple reason, is that again, is the sustainability and the economical reasons. If you have an environment that is working with IPv4 and works satisfactorily, the reasons for changing can only happen if the rest of the environment has changed, and then you are not getting your updates, or you're not getting a proper service if you remain in IPv4. For that to happen, I believe that is precisely about identifying IPv6 unique features that can be applied to improve the network. This is something that is already happening. We are already making some experiments about changing the current tunneling and mechanisms for guaranteeing mobility that you have in 3G, in 4G, and 5G with IPv6 features. that would imply that we would not need any longer, the tunneling mechanisms, the tunnel terminations and everything, and it would be more natural because the same network protocol would support mobility and rerouting and everything. If that succeeds, I hope it will succeed, then the progressive the progressive migration of the IPv4 islands into IPv6 will happen quickly. The same that happened, for example, I don't know, if you are, I guess that most of us have the age of remembering the days of SNA and DECnet and everything, and they were disappearing very fast because of IP. In the moment that everything was IP and maintaining the gateways, etc., was complex and complicated. So I believe that we succeed in the core of the mobile network as a mesh, as a means for convergence to leverage what IP has to offer. For sure, it will happen. If not, maybe we will be dealing for another decade or more of IPv4.
Absolutely, and well, I think it's been a theme of our whole discussion today. Of you just can't throw everything away. Yes, we might not start here if we were in an ideal world, but there's been a vast investment, of course, into what's gone before. Alan, I think you had a comment. We've only got a few minutes left, so if I could ask these final comments from Alan and Malik to be reasonably brief, sadly, so that we can wrap up.
I'll try to be very, very brief, actually, Caroline. So I don't think IPv6 will disappear in 6G. I think it's going to be the backbone, right? And now, having said that, IP as a protocol, perceived as a best effort, right, will not be, if you like, fit for purpose for all these time-sensitive, latency-sensitive, quality of experience sensitive kind of use cases. So there must be something that comes with it, right, on top of it, to make sure that it's not just a best effort approach to deliver on these use cases. In the long run, right, obviously, if the cost of investment, makes the case for a replacement or a substitute of IP, that would be the case. But that would be maybe in 7G or beyond.
Great, and Malik, you have the last word.
Yes, I think I understand where those questions are coming from, because obviously a number of industry players are looking at basically a next generation or new IP, and however you call it, to align with 6G value proposition. And basically, the argument is, the current TC over IP cannot handle, the workload or the overheads, brought by 6G applications. And then there is a need to rethink, IP protocol. But one thing is sure, and the history of technology has shown that if you want, to create a technology from scratch to displace existing technology, that is not going to work, right? So any innovation needs to be anchored on previous generation innovation. And for that reason, I agree with Alan. So IPv6 is going to be there. And if any innovation needs to happen, it needs to be anchored on existing IP protocol, right?
Great, thank you so much. There are so many other issues. Some of them have come up in the questions around energy and security and value chains, and I think we could talk all day about this subject, but sadly we can't, because we have only 1 minute left in our slot. So apologies to people whose questions we didn't have time to address. I hope we'll have other opportunities during the symposium, perhaps to communicate with the speakers and others on these topics, or indeed offline after the event. But for now, I would just like to say thank you so much to Diego, Nicolau, Valerio, Alain and Malik for a really stimulating discussion. You addressed some huge and rather daunting questions with great style and lots of interesting thoughts to share. I suspect we've raised more questions than we answered, but I think at this early stage of a new generation of technology, that's exactly what everybody should be doing, so that we encourage debate and as many ideas as possible to flow into the processes that I know you're all involved with through various organisations. So thanks so much. Thank you to all of the audience for listening and for your questions. And I will now wrap up the session.